All right, today we're doing Chapter 7, Section 7, adding and subtracting polynomials, and I think this starts getting to be quite a bit of fun, actually. So remember back, I wouldn't write this down, this stuff on the top here, but when we have this kind of thing here, back in the day, we said, well, if we're going to solve for x, first we need to combine the x's together and say, all right, so I have 3 x's here, 5 x's there, and usually then I would move the smaller one, because I like to avoid negatives as a general rule. So I get 2x minus 4 equals 7. And then next step we'd go and we'd add 4 to both sides. So plus 4, plus 4. And I get 11 equals 2x. And then we could divide by 2, and x is going to be 5.5. So again, I wouldn't write all that down. But the point I'm trying to make here is that this seems normal. This is what we've been doing. And we can't take this and say we have like 10 x's over on the left. That's not allowed. Or just 10, because this is 3 x's and this is just the number 7. So we can only combine things together if they have exactly the same variables. So here I have a 5x minus 3x. Well, we can combine those because they're both a certain number of x's. Here I have a 4, negative 4, and a positive 4. We could combine those and get like a plus 0. They cancel. 7 plus 4, we could combine those and get 11. So what I would write is you can combine terms that have exactly, emphasis on that word exactly, the same variables. So we can combine things with x's, like 3x and 5x, we can combine those. And things without x's, we can do it. Then the second thing I want to say is put answers in standard form. We looked at that in yesterday's notes, but that's basically the highest exponent to the lowest. And that's really to just like the constant, the number without an exponent. But you'll see those as we go through. If that doesn't totally make sense, check out these homework things. Okay, so if we go through and do some of these examples, well, for this first one, well, I have a 3x to the 4th here, and that's a positive, because nothing's written in front of it. And I have a positive 8x to the 4th. So 3 of them plus 8 more gives me 11x to the 4th. And then if I keep looking, all right, so I don't have an x to the 3rd or an x squared, but I do have a positive 5x's and a minus 2x's. So if I combine those, that gives me that I have 3 of those x's. So 11x to the 4th plus 3x. And then last but not least, I have a minus 7, or a negative 7 you could look at it, and a negative 4. So that's going to take me more negative and gets me down to minus 11. So final answer would be this, and it is in standard form because I have my x to the 4th first, then an x to the 1st, and then just a constant, a number without a variable in it. And that's really kind of adding, subtracting monomials. Monomials are going to be these single part things. So that's a monomial, that's a monomial, that's a monomial. So you can just do them like so. If we were to go down to this next one, the key to this is this first part here. I'm going to put it in red, so star right there. That's key, that you have to distribute the minus sign. So distribute the sign. And then once you do that, it's the exact same as the one we just did up above. And combine like terms. So this distributing the minus sign. So I'm looking at this first one. I have a binomial and I'm subtracting this monomial. So I really am only subtracting one thing. But I like taking this and rewriting it, so we don't need parentheses around that front because there's nothing here that we're distributing, not a minus sign or a 2 times that or anything. So 2x squared plus 6. But you can view this as though you have a negative 1. It's like a negative 1 times that second thing. So that gives me a negative 4x squared. And once we're there, we just do what we did above. So I have 2 of my x squareds, it's a positive 2, and I have a minus 4x squareds, or you could view it, I suppose, as negative 4x squared. But that gives me a total of minus 2, or negative 2x squareds. And then I have a positive 6 right there, so we could write a plus 6 there at the end. And that would be our final answer. And it's in that standard form. Do the exponents first, constants last. This next one, when we do the distributive, you can view this minus as though it's -1 times each of these clumps. So we have to -1 times the 4y to the third, -1 times the -6y squared, -1 times positive 7y, and -1 times the -9. So first I'm going to write out that first thing. So I have 3y to the third minus y squared, and then a plus 7. And then, see if I can erase those quick a second. I'm going to do those in different colors just to make sure we're all on the same page. So this -1 times that gives me a minus 4y to the third. So it's a -1 times a positive 4. Then I have my negative, or my subtraction sign, times a -6y squared. So negative times a negative gives me a positive 6y squared. And then I have my -1 times a positive 7y. That's going to make it a minus 7y. And then last but not least, I have my -1 times my -9, makes it a plus 9. And now it's real similar to example 1. We just go through and we combine like terms. So if I look, I have 3y to the thirds and a minus 4y to the thirds. So that's going to give me a -1. I'm just going to write it as minus y to the third. That's a little bit more simplified than if I would put a -1 in there. And simplified is better. All right, then I have a y squared. So I have a minus 1y squared plus 6y squared. Those will partially cancel out. Give me a plus 5y squares. Ooh, now I have this minus 7y, and I don't have one up here in the front. I don't have a y to the first like this. So that means there's just nothing to combine it with. So we have just that minus 7y. Just drops right down to the bottom. And then last but not least, I have my constants, my numbers without variables. I have a positive 7 and a positive 9. Gives me positive 16. So that there, my friends, is our answer in standard form. Example 4 actually is a little bit easier than this last one. You could look at it, and this is kind of a dumb way to look at it, I suppose, but just like up above, we did this -1 here. View this negative as a -1 times each of those. You could view this as a positive 1 if you wanted to, times each of those. But if you distribute a positive 1 times each of those 3 terms, or each of those 3 clumps, it really just doesn't change anything. So you could do one of two things. When you have addition, you could go through and just rewrite everything like I'm going to do here, but really the parentheses just kind of drop out. That positive 1 times a -8 n to the fourth just gives me -8 n to the fourth. Positive 1 times a -1 n squared just gives me minus n squared plus 9. So you could rewrite it like that, or you could just go with that top thing and just kind of ignore the parentheses, just kind of like either scribble them out or pretend they're not there for each of those. And it's really just a combining like terms. So I'll try to go quickly. So I have a positive 5 n to the fourth. I'm going to take 5.4 n to the fourth. I'm going to take away 8, which should give me a minus 2.6. So negative 2.6 of my n to the fourths. Then I have a minus 8n squared minus another 1n squared. Gives me a minus 9n squared. And last but not least, I have my -2 and my positive 9 gives me a positive 7. So that's it, really, for the whole section, I guess. So that's it for the section. Yeah, it's just combine things that are the same. If you get stuck, let me know. But we should have covered those 3 I can statements there. And yeah, it looks like I did give answers for a whole bunch, but I really kind of shortened it up. If you want to just do the evens here, you could just do the evens like right there. But I did give answers for all of them in case you want more practice. But I think you'll be fine.